Okay, this is, I believe, Target 9A Pythagorean Theorem retake video. Here are some cheat sheets you get to use finding a missing side. The next one would be finding a missing angle. And then here's 30, 60, 90, 45, 45, 90, and then write acute or obtuse. Okay, let me grab a color. Red looks good. We need to find the length of the missing side. So there's a missing side. If you look at the to find a side of the cheat sheet, it says, if possible, use a Pythagorean theorem. And it's possible to use a Pythagorean theorem when you know two sides. And lo and behold, I knew two sides, so I can use a Pythagorean theorem. And remember, the Pythagorean theorem is length squared plus length squared equals the hypotenuse squared. So I need to find the hypotenuse. That's the side across from the right angle. That's the hypotenuse. If I put the hypotenuse in the wrong place, I'll get the wrong answer. So my hypotenuse is x. So x squared, and then my legs are 9 and 12. Now 9 squared is 81. 12 squared is 144. That equals x squared. If I add 81 plus 144, I get 225. So I get x squared equals 225. Then I take the square root, and the square root of 225 happens to be 15. So my answer is 15. Okay, problem number 2. I need to find the length of the missing side if the hypotenuse is 13. So it gives us this side, which is 5. Remember, again, the hypotenuse is across from the right angle. That's 13. So that must be the missing side. And again, I can use the Pythagorean theorem since I know two of the sides. So remember, that's legs squared plus legs squared equals hypotenuse squared. So my hypotenuse is 13, and my legs are x and 5. So x squared, 5 squared is 25, 13 squared is 169. I can subtract 25 from both sides, and I get x squared equals 144. Then I take the square root, and I get x is 12. Okay, number 3. A triangle has side lengths 16, 20, and 12. So I need to decide if that's obtuse, acute, or right. And the rules are very nicely written down right here for us. So it says leg squared plus leg squared and then the longest. So I need to know what the longest is. And first I have to make sure it's a triangle. So I'm going to add 16 and 12 together, the two smaller sides, and I get 28. That number has to be bigger than the number I circled, and it is. So that means I can go ahead and attempt this problem now. So then I say my longest side is 20. And I shouldn't put an equal sign there because I actually don't know if they're equal. That's what I'm testing, is to see if they're equal. And so my sides are 16, and 12. So 16 squared is 256, I believe, and 12 squared is 144. And I want to know if that's going to be equal to or greater than 400 or less than. So 20 squared is 400. I'm just double checking my math here. Yep, definitely 400. And 16 squared, 16 squared is definitely 256, and I know 12 squared is 144. So 256 plus 144 is, you guessed it, 400. So I get 400 is equal to 400. So they're equal. So I look at that. Equal, that means it's a right triangle. Okay. Number 4, same kind of problem. I circle the longest side. 4 plus 5 is 9. So 9 is bigger than 6, so this is a triangle. Then I do 4 squared plus 5 squared. I want to know how that So I made a little mistake. I'm not sure what this says, but I'm going to write it over here. It should be 4 squared plus 5 squared equals 6 squared. That's correct, but 4 squared is 16, 5 squared is 25, and 6 squared is 36, not 23, which I guess I wrote. I'm not sure if I deleted it all the way or not. Anyway, when I add 16 and 25, I get 41. And then 36, I have to point at the smaller number, and that's this sign, so it's definitely acute. So this is an acute triangle. Sorry about that. 5. Okay, so something similar with problem number 5. We have side lengths 13, 21, and 30. Again, the longest side is 30, so 13 and 21. That is 34. And 34 is most definitely bigger than 30, so it's a triangle. Then the 30 is the longest, so that goes here. And then 13 and 21. 13 is 169, 21 I believe is 441, and 30 is 900. I'm just going to double check my math there. So 13, 169, 21, yep, 441, and 30 is 900. So 169 plus 441 is 610. And 610 and 900. And again, I have to point at the smaller number. So that's this, and that is that, and that means it's obtuse. Okay, number 6. We have a firefighter that leans an 18-foot ladder against a tree. So that's my tree. And I got a ladder leaning against a tree, and I don't know how far up the tree it reaches, so I'm not going to say it goes to the top. I don't know. I know my ladder is 18 feet. And I know that the base of the ladder is 3 feet from the ground. And the kitten is way up here at the top at 23.3. And I want to know if the ladder is 3 feet from the ground, if it'll reach the cat. So I need to know how high this is right here, how high up the tree this ladder reaches. So I'm going to say 3 squared plus x squared equals 18 squared. Again, this is a Pythagorean theorem problem. This is the hypotenuse. I know 2 of the sides, so I can use the Pythagorean theorem. So 9 plus x squared equals 18 squared. I believe that's 324. I'm just going to double check that. And I'm right. So then I'm going to do 324. I'm going to subtract 9 from both sides. I get 315. And then I have to take the square root of both sides. And I get the square root of 315. Oops, that's 12. I get 17.7. Now the ladder, or the kitten, is 23.3 feet up, and it's asking if the ladder can reach the kitten. So that means, does the ladder go 23.3 feet off the building? And it doesn't. It only goes 17.7. So the answer is no. Okay, you may have been able to think of another way to do this. And as long as you can write a good explanation about why it won't work, you can use maybe the more obvious solution to this problem. Okay, the following problems you have to do on your own. Show them to myself, a TS teacher, a math lab teacher, or a help lab teacher. Here's problem number 1. Here's 2, 3, 4, 5, and 6. Good luck.